Okay, so let's talk a little bit about closures. What exactly are they and how do we use them? So as you can see, we have two classes here, which are two robots, a cooking robot and a shopping robot. And both of them can do one specific thing. And they're very collaborative robots. They help each other. So the shopping robot can buy groceries and the cooking robot can make breakfast. But if you notice, the cooking robot make breakfast method takes an input of a function that outputs a void. So it's a function without any input parameters and it outputs nothing. So before it can make breakfast, it needs to buy the ingredients, which is only something that the shopping robot can do. So how do closures play a role in this dynamic? Let's take a quick look here in making breakfast. Alright, so we instantiate a cooking robot using the cooking robot class, and we instantiate a shopping robot using the shopping robot class. If we want to make breakfast, we can say the cooking robot makes breakfast. And as you can see, it will take in an input of a function that outputs a void. We can have the shopping robot help out the cooking robot. So we can go shopping robot dot buy groceries. So now, when the cooking robot makes breakfast, the shopping robot will help her buy the ingredients first. So then when we play this playground, as you can see, the cooking robot will be able to successfully make breakfast because the shopping robot will be able to shop for groceries and the cooking robot will be able to make breakfast right after that. Okay, so what if the cooking robot wanted to do the shopping herself? This is where we would need a closure. See, a closure is essentially a function without a name, and we can use a closure instead of asking the shopping robot for help. So we can do this by typing in cooking robot make breakfast, and we type in buy ingredients. And then instead of asking the shopping robot for help, we can use a closure. So a closure is denoted by this syntax, two curly brackets. So inside the closure, we can put anything we want. We can put a function because this entire thing is an unnamed function. So for example, we can print I'm the cooking robot and I'm going to shop myself. So if we go ahead and run this and let's comment out this first one, as you can see, the cooking robot will be able to shop herself and will be able to make breakfast without ever having to call for the shopping robot buy grocery method. So the shopping robot was never needed in the first place because we used a closure to create our own function inside of buy ingredients. So this function has no name at all. It's just there, and that's a closure. And also there's this thing called a trailing closure, because in Swift, whenever we use a closure as a last parameter of a function, we can move it outside. So we can move this entire closure outside of the method, and we can remove the parameter name. And this is called a trailing closure, and it does exactly the same thing as it did before. So if we go ahead and play this playground, the cooking robot will still be able to cook because it will still be able to shop for itself and it will be able to make breakfast. So that's the basics of closures.